Simplify the expression using the properties of exponents. Assume all variables are positive. First, notice that the expression involves powers of the same base, x. When dividing powers with the same base, use the quotient of powers rule, which states that you subtract the exponents. Subtract 1 by 1/2 gives 1/2. So the power of x simplifies to x to the power of 1/2. Next, we have a power raised to another power, which requires a power of a power rule, where we multiply the outer exponent by the inner exponent. Since you're working with a product, the outer exponent is distributed to each factor. Applying this, we multiply the exponents for each term. This results in x to the power of 1/3 and y squared. This is your final answer, but depending on the question, you may have to express a rational exponent as a radical. The denominator of the fraction determines the index of the radical. For x to the 1/3 power, this is equivalent to the cube root of x. This gives us y squared times the cube root of x. Write the reduced radical form of the expression. First, rewrite the roots as rational exponents. The nth root of a number can be expressed as the base to the power of 1 over n. Using this rule, the sixth root can be written as the base raised to 1/6, and the cube root as the base raised to 1/3. Next, rewrite 1/3 as 2/6. You will see why in a minute. We can manipulate the rational exponent by separating the numerator and the denominator. Now the expression can be written with 1/6 on the outside and the remaining term squared on the inside. When we raise 2x squared to the second power, it simplifies to 4x to the fourth power. At this point, both terms are raised to the power of 1/6, allowing us to multiply the bases together. Remember to add the exponents of like bases when multiplying powers. This gives us 32x to the 7th power. Finally, rewrite the rational exponent back into a radical with the index of 6. Simplify further by observing that x to the 7th power can be broken into x to the 6th power times x. Since the sixth root of x to the 6th power is x, the final expression becomes x times the sixth root of 32x. Next, we have a cube root of 2n over 9m. Using the quotient property of radicals, we can separate the numerator and the denominator. To rationalize the denominator, think about multiplying by a value that makes the denominator becomes a perfect cube. 27m cubed is a perfect cube, so we can multiply both the top and bottom by the cube root of 3m squared, which ensures that the bottom results in 27m cubed. Multiplying the top, we get the cube root of 6nm squared. Taking the cube root of 27m cubed on the bottom gives us 3m. Since the top radicand doesn't contain any perfect cubes, this is the simplest form of the expression. To rationalize the denominator, we multiply both the top and bottom by the conjugate of the denominator. In this case, the conjugate is 2 minus square root of 3. When multiplying the denominator, we use the difference of squares formula. The first term 2 squared equals 4, minus the square root of 3 squared equals just 3. The denominator simplifies to 1. For the top, we multiply 5 minus the square root of 2 by 2 minus the square root of 3. To do this, we use the distributive property, also called the FOIL method. First, we multiply the first terms, which gives 10. Then we multiply the outside terms, which gives negative 5 times the square root of 3. Next, we multiply the inside terms, which gives negative 2 times the square root of 2. Finally, we multiply the last terms, which gives the square root of 6. Since none of these terms are alike, we cannot combine them any further. Because dividing by 1 doesn't change the value, the final simplified expression is 10 minus 5 times the square root of 3 minus 2 times the square root of 2 plus the square root of 6.